You are a tall, powerful Homo sapiens, standing under a prehistoric sky. The air smells raw, untamed. Around you, naked figures move silently, your ancestors, strong and wild. No clothes, no cities, no rules, just survival. The warm sun bathes your skin, a primal comfort, and you feel the rough, ancient earth yielding slightly beneath your bare feet, connecting you directly to the planet's deep past. In the distance, strange animal calls echo across the vast open plains, a symphony of wildness that both thrills and warns. But how did we get here? How did life begin on this planet, long before humans walked these lands? Tonight we'll drift back, billions of years, to the very start. Tonight, we're going to journey back in time. Not thousands, not millions, but billions of years, to discover how life began on our incredible planet. It's a story of cosmic dust, of fiery oceans, of tiny invisible sparks, and of the slow, patient unfolding of complexity, leading to the intricate tapestry of life we see today, including your very own existence. So, dim the lights, take a deep, calming breath, and let your mind float through the vastness of time. Like a feather carried on an ancient breeze, gently, effortlessly. Allow the gentle rhythm of this story to guide you, to soothe you, to carry you back through the eons. And let's begin. Imagine, if you can, a world utterly devoid of life, a planet still in its infancy, raw and untamed, a cosmic infant screaming into the void of nascent space, its very existence a violent, energetic burst of creation and transformation. Our story begins approximately 4.5 billion years ago, in the chaotic, violent crucible of the early solar system, a maelstrom of colliding debris and nascent celestial bodies, swirling in a cosmic dance of creation and destruction, each impact adding to its growing mass, building a world from scattered dust and gas, coalescing under the relentless pull of gravity. Picture the Earth not as the vibrant blue-green orb you know, teeming with life and shrouded in soft white clouds that drift lazily across azure skies, but as a swirling, incandescent sphere, a true molten surface of glowing rock and liquid metal, a vast, churning ocean of fire that stretches to an endless, hazy horizon, where the very air shimmers with unbearable heat, distorting the view like a mirage, making the boundary between liquid rock and choking atmosphere indistinguishable. The ground beneath your imagined feet would be a viscous, glowing lava, constantly churning, bubbling with trapped gases that burst forth in fiery plumes, and releasing immense columns of superheated steam and noxious gases into a nascent atmosphere. A perpetual, fiery breath that choked the nascent air with its heavy, acrid exhalations. A suffocating embrace of lethal compounds. This wasn't a gentle, flowing lava that you might see from a distant volcano today. Imagine colossal volcanic eruptions on a scale unknown in modern times, constantly tearing open the thin, forming crust. Fissures miles long would split the surface, great gaping wounds in the Earth's fiery skin, spewing rivers of incandescent rock that flowed like molten rivers, carving ephemeral channels across the glowing landscape, while towering stratovolcanoes, born and destroyed in rapid succession by the planet's internal turmoil, would erupt with cataclysmic force, sending shockwaves across the globe, rumbling through the very core of the planet, shaking its nascent foundations. Each eruption would inject unimaginable quantities of sulfur dioxide, carbon monoxide, hydrogen cyanide, and other volatile compounds into the already dense atmosphere, further thickening the veil and contributing to a perpetual, suffocating haze that blocked out all but the most intense light from the distant, young sun, casting the world in an eternal, ominous twilight. There would be no solid ground to stand on. no stable footing, only a ceaseless, fiery ocean, reflecting the angry, reddish glow of the sun through thick, primordial clouds. A hellish landscape of unimaginable, searing heat. The heat would be unimaginable, a searing, suffocating blanket that would instantly vaporize anything familiar, any trace of water, any organic molecule, reducing it to its constituent atoms in a flash of superheated energy, leaving nothing but superheated vapor and swirling gases, a truly sterile environment, relentlessly purged of any complexity. The air itself would shimmer with the intense thermal energy, creating distorted mirages of heat and light that danced above the incandescent surface, distorting any view, making the horizon ripple like liquid fire, an ethereal, dangerous beauty that was utterly inhospitable, a warning of the planet's raw power. The constant roiling of the molten rock would create a low, resonant hum, a deep, vibrational thrum that would permeate everything, a sound of planetary birth, a cosmic groan that echoed through the formless void, a symphony of geological power, a constant, deafening roar from the planet's core, a primordial cacophony. The entire surface would be a canvas of angry orange and deep, glowing red, punctuated by brighter fissures where fresh magma erupted, spraying incandescent droplets into the choking air, creating temporary fountains of fire that arced across the darkened sky. A truly alien and hostile environment, utterly inimical to life. A world of pure, unadulterated chaos and raw, untamed energy. A planet still screaming into being. The very concept of quietude would be unknown, replaced by the ceaseless, thunderous symphony of a planet being born, a constant, overwhelming roar. Above this fiery landscape, the skies would be a terrifying spectacle, a constant, violent display of cosmic fury, a relentless bombardment from the remnants of the solar system's formation, a final, tumultuous clearing of debris. Not the clear, blue expanse of today, with its gentle breezes and scattered cumulus clouds, but a perpetual, storm-racked canvas, lit by the constant, blinding flashes of meteor showers. These weren't gentle sprinkles of shooting stars, ephemeral streaks of light that momentarily graced the night sky before vanishing into obscurity. These were relentless bombardments, giant chunks of rock and ice, some the size of mountains or even small countries, slamming into the planet with cataclysmic force, each impact sending tremors through the entire globe, shaking its very foundations, creating seismic events of unimaginable magnitude that would ripple across the fiery surface, leaving momentary, incandescent scars. Each impact would send colossal shockwaves through the molten surface, creating immense craters that would quickly be swallowed by the flowing lava, erasing any trace of their momentary existence, a fleeting scar on a fiery face, and throwing vast amounts of dust and debris even higher into the already choked atmosphere, creating an even thicker, more impenetrable veil of particulate matter, further obscuring the sun and plunging the surface into deeper gloom, a perpetual twilight born of cosmic violence. This early atmosphere was a suffocating, alien brew, entirely inhospitable to life as we know it, a corrosive, poisonous blanket that pressed down with immense weight, utterly unbreathable, a gaseous prison of lethal compounds, heavy and stifling. It was thick with toxic gases, vast quantities of carbon dioxide, released from the planet's interior as it outgassed, methane and ammonia, potent greenhouse gases that trapped immense heat, contributing to the planet's fiery state. Hydrogen sulfide, with its acrid, rotten egg smell, a constant, nauseating presence that would sting the nostrils and burn the eyes. And hydrochloric acid, all belched forth from countless volcanoes that dotted the planet's surface, constantly erupting, spewing their internal contents into the sky, creating a perpetual chemical haze, dense and suffocating, a perpetual chemical fog that hung low and heavy. There was no free oxygen yet, not a single molecule of the life-giving gas that sustains you now, not a breath of fresh air to be found anywhere across this desolate sphere. Only a cocktail of lethal vapors that would instantly corrode any organic matter, making life utterly impossible. Breathing would be impossible. The air a corrosive poison, thick and heavy, pressing down with immense pressure. A suffocating weight that would crush any modern lungs, burning them from within with its noxious vapors, leaving them scorched and useless. A slow, agonizing demise. The sky would likely be a perpetual murky red or orange, perpetually overcast, never truly clearing. The sun a dim, distant smudge, its light struggling to penetrate the dense, toxic clouds, casting a perpetual, ominous twilight. A world without clear dawn or dusk, only a perpetual dim glow that hinted at the inferno below. A world of perpetual menace. The sounds would be a deafening symphony of impacts, volcanic eruptions, the ceaseless roar of falling debris, and the constant rumble of the planet's internal turmoil. A constant, thunderous cacophony that would overwhelm all other senses. A world of pure, unadulterated noise. A violent, chaotic cradle of planetary formation. A relentless, auditory assault. A soundtrack to planetary creation. The very light that filtered through this atmosphere would be alien. A dim, ruddy glow that painted the entire landscape in shades of ochre and rust. A world seen through a veil of smoke and fire. As eons passed, measured in millions upon millions of years, a timescale almost impossible for the human mind to grasp. A stretch of time so vast, it renders human conception of duration meaningless, fading into an endless, unimaginable duration. The Earth, though still violent and active, began its slow, deliberate cooling, a gradual process of planetary maturation, like a giant cooling forge, slowly solidifying its molten core, its surface gradually darkening from incandescent orange to a dull, dark red, then to a hardened black crust. The molten surface gradually hardened, forming a thin, fragile crust, a mere skin over the fiery interior, a delicate shell that would eventually become continents and oceans, though still frequently fractured by volcanic eruptions and tectonic shifts, creating new landmasses and deep fissures, constantly reshaping its nascent face. A dynamic, ever-changing surface carved by internal forces, a restless, living planet that continued to groan and shift with titanic power, its surface scarred by its tumultuous birth. And then, the rain began. Imagine a deluge of truly biblical proportions, a downpour of cosmic scale, not lasting days or weeks, or even centuries, but lasting millions of years. As the planet cooled, as its incandescent surface reluctantly gave way to a hardened crust, as the temperature slowly, painstakingly dropped below the boiling point of water, the immense amounts of water vapor that had filled the atmosphere, released from the molten rock and delivered by icy comets that bombarded the early Earth, condensed. It fell as scalding rain, hitting the still hot surface and instantly flashing back into steam, creating colossal clouds of vapor that rose back to the heavens, only to condense and fall again in an endless, agonizing cycle, a perpetual hydrological torment, a relentless, burning rain that carved its way through the landscape, eroding the nascent rock, shaping the very first valleys and basins, collecting in the lowest depressions. This ceaseless downpour would have created a global mist, a perpetual fog rising from the steaming surface, obscuring everything. Over inconceivable stretches of time, this ceaseless precipitation, drop by drop, torrent by torrent, began to collect in the lowest basins of the newly forming crust, gradually, patiently, giving birth to the oceans. These early oceans were not the clear, blue, life-filled waters of today, teeming with vibrant ecosystems and shimmering with sunlight filtering down to clear depths. They were likely warm, murky, and rich with dissolved minerals and chemicals, a primordial soup, a dense, mineral-laden broth, constantly agitated by the planet's internal heat and the lingering impacts from space, creating vast, turbulent currents and violent undertows, a churning chemical cauldron, a vast planetary experiment, a brew of potential, a complex chemical stew. The constant rain would have created a deafening roar, a perpetual waterfall across the entire globe, turning the surface into a vast, steaming cauldron, a world dominated by the sound of falling water, a relentless pounding rhythm that would never cease, a watery crescendo that filled the world, a constant, overwhelming presence that slowly softened the planet's fiery edges, carving out its future. The pressure would have been immense, the light dim, filtered through dense clouds and murky waters, and the very air thick with steam and chemical vapors, a heavy, suffocating atmosphere that clung to the surface, making it difficult to even conceptualize the immense forces at play, the sheer scale of the planet's infancy, its raw, untamed power. This was the silent Earth, a world of fire and water, of rock and gas, utterly lifeless, yet holding within its turbulent depths the very raw ingredients for everything that was to come. The fundamental building blocks of life, waiting for the right conditions, the perfect alignment of chemical forces, the precise moment for creation. It was a planet waiting, unknowingly, for the first whisper of life to stir, for the spark of creation to ignite in its primordial depths. A vast, empty stage awaiting its first actors, its first microscopic protagonists, poised on the brink of an unimaginable transformation. A silent, cosmic anticipation. A long, patient wait for life to begin its journey. A story slowly, quietly preparing to unfold. A planetary canvas ready for the first brushstrokes of biology. From the violent, silent Earth, our journey now takes us into the deep, dark, and incredibly dynamic heart of the early oceans, where the first whispers of life began to stir, a profound mystery unfolding in the darkness, driven by unseen chemical forces and immense geological energy. Picture yourself at the bottom of this vast, murky, ancient sea, where sunlight cannot penetrate, where the pressure is immense, crushing, a weight of unimaginable density pressing down from all sides, and the water is thick with dissolved minerals, a dense, alien broth, utterly unlike the clear, oxygenated waters you know. A world of perpetual twilight and chemical richness, a vast, unexplored frontier. Here, in the abyssal plains, far from the chaotic surface and its constant bombardments, were the hydrothermal vents. Imagine colossal cracks in the Earth's crust, like giant underwater chimneys, some towering hundreds of feet high, forming intricate, mineral-rich structures that looked like bizarre, alien cities rising from the seafloor, spewing superheated, mineral-rich water from the planet's interior, a constant geyser of chemical energy, a perpetual fountain of raw materials bubbling up from the Earth's fiery core, a direct connection to the planet's inner furnace, its primordial heart, a source of endless, potent chemical reactions. These vents, often referred to as black smokers due to the dark, sulfide-rich plumes they emitted, or white smokers for their lighter barium, calcium, and silicon-rich emissions, would have glowed faintly with a strange, otherworldly light. Perhaps a dull red or orange from the extreme heat, a bioluminescent flicker in the perpetual gloom, illuminating the murky water around them with an eerie luminescence, creating a bizarre, alien landscape of towering formations and shimmering heat haze, a hidden world of incandescent rock and churning fluid, a truly unique environment, vibrant with unseen chemical activity, a realm of constant chemical exchange. They were oases of chemical energy, providing a constant flow of hot, chemically reactive fluids, rich in hydrogen sulfide, the telltale smell of rotten eggs, though you wouldn't smell it here, only sense its chemical presence. Iron, methane, ammonia, and other essential elements. A veritable buffet of raw materials bubbling up from the planet's core. A constant source of chemical potential, perfectly suited for the dawn of life, where inorganic compounds could spontaneously react and combine in complex ways, forming ever more intricate molecules. The steep chemical gradients between the hot, acidic vent fluids and the cooler, alkaline seawater provided a natural energy source, a proton gradient that some scientists believe could have driven early metabolic reactions, mimicking the energy production within modern cells, a primitive form of chemiosmosis. This was a stark contrast to the sun-drenched surface, a dark, hot, chemically vibrant environment that bypassed the need for sunlight, which was still largely blocked by the thick, cloudy atmosphere above, making photosynthesis impossible and unnecessary in this realm, where light could not penetrate. A world of chemosynthesis, powered by Earth's own internal fires, a deep-sea cradle for the earliest forms of life, undisturbed by the chaos above, a realm of constant, subtle creation, a protected laboratory. Within these extreme environments, warmed by internal heat, or perhaps in shallower, sun-warmed pools on the surface, constantly agitated by tidal forces and volcanic activity, a miraculous process began. The formation of simple molecules forming amino acids. These were the fundamental building blocks of proteins, the complex machinery of life, the very letters of life's alphabet, waiting to be arranged into meaningful sequences, into the code of existence itself. The first words of biology, waiting to be spoken, to be written into the fabric of the planet. Imagine countless chemical reactions occurring simultaneously, driven by the intense heat from the vents, the raw energy from frequent lightning strikes that ripped through the heavy atmosphere, the ultraviolet radiation from the sun, unfiltered by an ozone layer which had not yet formed, allowing lethal radiation to reach the surface, providing another powerful energy source, and the raw chemical potential of the early oceans, a vast, churning laboratory on a planetary scale, constantly experimenting with new combinations and permutations, a grand cosmic experiment unfolding over eons. Simple inorganic compounds, like carbon dioxide and water, began to combine with nitrogen and hydrogen from the atmosphere, forming more complex organic molecules, like sugars, the fuel of cells, providing energy for their functions. Lipids, the building blocks of membranes, creating boundaries and compartments, and nucleotides, the components of genetic material like DNA and RNA, the precursors to life's macromolecules. These simple organic compounds, perhaps carried to Earth by meteorites and comets, seeding the planet with extraterrestrial chemistry, bringing in elements from the cosmos, or formed directly in the atmosphere and rained down into the oceans, began to link together. It was a slow, patient, almost imperceptible dance of atoms and molecules, guided by the immutable laws of chemistry, gradually forming longer chains, more intricate patterns, more complex structures, a molecular ballet unfolding over millions of years, a silent, unseen creation piece by painstaking piece, a gradual assembly of complexity from simplicity, a quiet miracle of self-organization. These were not yet living things, but the essential components, the alphabet of life, waiting to be arranged into meaningful words and sentences, into the very language of biology, a potential code ready to be written, a blueprint for existence, a library of chemical information slowly, painstakingly being compiled, molecule by molecule, building the very foundation of life. The presence of clay minerals on the seafloor or in shallow pools may have acted as catalysts, providing vast, intricate surfaces for these molecules to concentrate and react. Acting as primitive reaction chambers, fostering their assembly and polymerization, allowing them to grow in complexity and form larger structures, accelerating the process of chemical evolution, guiding the nascent chemical dance towards greater order and function. Acting as scaffolds for life. Consider also the crucial role of warm pools and lightning storms on the surface, offering an alternative, equally energetic cradle for life's genesis, a complementary pathway to the deep-sea vents, proving that life could have arisen in multiple ways, in various environments, each with its unique chemical recipe and energy source. While the deep-sea vents provided one potential origin point, shallow, sun-warmed ponds, constantly agitated by torrential rains and illuminated by frequent, spectacular lightning strikes, offered another, a different kind of energetic environment for chemical evolution. A surface-based laboratory constantly electrified and exposed to the elements. A dynamic, open-air reactor. The early atmosphere, rich in methane, ammonia, and water vapor, would have been a perfect conductor for colossal electrical discharges, far more powerful and frequent than any modern thunderstorm, illuminating the entire sky with searing, blinding flashes that stretched for miles, a constant, violent light show that lit up the primordial night, cracking across the heavens with deafening roars. Each lightning bolt, a searing, blinding flash of energy, would have ripped through the air, providing the raw power needed to break apart simple inorganic molecules and recombine them into more complex organic compounds. A violent act of creation on a grand scale. A cosmic forge where new chemicals were hammered into existence from raw elements. A constant, energetic input. An atmospheric experiment constantly generating new possibilities. These compounds would then wash into shallow pools, where cycles of evaporation and refilling would concentrate them, allowing them to interact and polymerize, forming longer, more intricate molecules, like nucleic acids, the blueprint of life, carrying genetic information, and proteins, the workers of the cell, performing catalytic functions. The very building blocks of cellular machinery, becoming denser and more reactive with each cycle of drying and re-wetting, promoting self-assembly and the formation of complex polymers, driven by the fluctuating conditions. Imagine the constant crackle and boom of thunder, a deafening symphony that never ceased, punctuated by the blinding flashes illuminating the steaming landscape. The air thick with the pungent smell of ozone from the lightning's interaction with oxygen precursors, and sulfur, a chaotic, energetic ballet of creation, a planetary experiment unfolding in real time, a constant natural laboratory constantly generating new possibilities, new chemical pathways, new molecular structures, a dynamic, ever-changing environment. In these dynamic environments, the simple molecules began to self-assemble, forming longer chains, more intricate patterns, and eventually, the first rudimentary, self-replicating molecules, perhaps early forms of RNA, which possessed both genetic information and catalytic properties, acting as both blueprint and builder. A molecular Swiss Army knife. a truly revolutionary breakthrough, a molecular miracle that brought forth the first glimmer of self-perpetuation, the ability to make copies of themselves, to pass on their chemical instructions, the very essence of life, a spark igniting in the primordial soup, a tiny invisible flame of existence beginning the long journey of evolution. Eventually, through processes still debated by scientists, but driven by these relentless chemical and energetic forces, these complex molecules, including early forms of RNA, which uniquely could store genetic information and catalyze reactions, acting as both blueprint and builder. A molecular Swiss Army knife, a jack of all trades, capable of both information storage and enzymatic activity, began to enclose themselves within protective membranes. These membranes, formed from simple lipids, fatty molecules, would have spontaneously arranged into spherical structures in water, creating a boundary, separating the internal chemistry from the external environment, allowing for a more controlled and stable internal state, a crucial step towards true life and independent existence. A self-contained unit, a tiny world within a world, capable of maintaining its own internal environment, a true cellular entity. This was the birth of the first primitive cells, known as prokaryotes. Picture them as incredibly tiny, microscopic sacs, perhaps no larger than a speck of dust, yet containing within them the miraculous ability to self-replicate, to make copies of themselves, ensuring their lineage and perpetuating their existence for countless generations, and to carry out basic metabolic processes, extracting energy from their environment to fuel their internal machinery, to grow and divide, to maintain their internal order, to adapt and evolve, to respond to their surroundings, to survive and thrive. They were simple, lacking a nucleus or complex internal structures. No mitochondria, no chloroplasts, no endoplasmic reticulum, no Golgi apparatus. Resembling modern bacteria and archaea, yet they were undeniably alive. The first true living entities, the original inhabitants of this primordial world. A silent, vast kingdom of microscopic life, thriving in the unseen depths. These were the pioneers, the very first living entities on Earth. The original inhabitants of this primordial world, silent and unseen, slowly multiplying, filling the oceans with their numbers, a vast, unseen empire of living cells, each a tiny miracle of self-organization and self-perpetuation, a testament to the power of the simplest forms of life. They were anaerobic, meaning they thrived in the absence of oxygen, which was still largely absent from the atmosphere and oceans, consuming the abundant chemicals in their environment for energy, perfectly adapted to their primordial world. A world where oxygen would have been a deadly poison, a world they had mastered, unknowingly setting the stage for its dramatic transformation. They would have floated or drifted through the warm, murky oceans, multiplying slowly, silently, utterly invisible to any macroscopic observer, a hidden world of microscopic life, laying the foundation for all future biodiversity, a vast, unseen empire of living cells, patiently waiting for the next great evolutionary leap, a quiet, humble beginning to an extraordinary story, a testament to the power of the simplest forms of life, a silent, persistent force of nature. For billions of years, the Earth's oceans teemed with these simple, anaerobic prokaryotes, a hidden world of microscopic life thriving in the chemical-rich waters, a vast, unseen biosphere of single-celled organisms, evolving and adapting in an oxygen-free environment. They had adapted perfectly to their world, a primordial soup that was their perfect home, extracting energy from chemicals like sulfur compounds or fermenting organic matter, living in a delicate balance with their environment, thriving in conditions that would be lethal to almost all modern life. They filled every available niche in the anoxic oceans, forming vast, unseen communities, a testament to the incredible diversity that could arise even in the simplest forms. A silent, thriving kingdom in the depths. They lived in a world without free oxygen, a world that would be instantly lethal to most life forms today. A truly alien environment, bathed in methane and carbon dioxide, a reducing atmosphere that was utterly inhospitable to you. A world defined by the absence of the very gas that sustains your breath, a planet holding its breath, waiting for a change. But then, a new kind of life emerged. A revolutionary force that would fundamentally reshape the planet's very atmosphere and oceans, leading to an event known as the Oxygen Revolution, or more dramatically, the Great Oxidation Event. A planetary transformation on an unprecedented scale, a shift that would define the future of life on Earth, changing its very essence, its very breath, its very color. This pivotal moment began approximately 2.5 billion years ago, with the appearance of cyanobacteria, often called blue-green algae, though they are true bacteria. Masters of a new, incredibly powerful energy source. Sunlight itself, the ultimate source of energy for Earth's surface, abundant and inexhaustible, radiating down from the young sun, a constant, limitless supply of energy. Imagine these tiny, single-celled organisms, perhaps forming vast, shimmering mats near the surface of the warm, shallow seas, clinging to submerged rocks or floating freely, their bodies absorbing the sun's energy, creating expansive, slimy colonies that covered vast areas, forming a living, photosynthetic carpet that slowly but surely changed the face of the planet. Molecule by molecule, breath by breath, an invisible force of unimaginable power, quietly transforming the world, a silent, green revolution. Their innovation was truly groundbreaking, a biological paradigm shift that would alter the course of planetary history on an unimaginable scale. They developed the ability to perform photosynthesis, a complex biochemical process where they used sunlight, water, and carbon dioxide to create their own food, sugars, essentially converting light energy into chemical energy, and in doing so, they released oxygen as a waste product. Unlike earlier, anoxygenic forms of photosynthesis that used compounds like hydrogen sulfide, cyanobacteria, had evolved the ability to split water molecules, a far more abundant resource, releasing oxygen as a byproduct. This gas, oxygen, was then a poison to most existing life, a toxic byproduct of their metabolic process, unknowingly initiating a global environmental crisis for others. A silent chemical war that would reshape the biosphere from its very foundations, leading to the first great environmental catastrophe caused by life itself, a planetary-scale pollution event. At first, this oxygen was a silent, invisible killer, a toxic byproduct in a world unaccustomed to its presence. A slow, insidious poison spreading through the ancient waters, reacting with everything it touched, fundamentally altering the chemistry of the oceans. It began to dissolve into the oceans, reacting immediately with the abundant iron dissolved in the water, which had accumulated over eons from volcanic activity and hydrothermal vents, making the oceans a murky, iron-rich solution, a vast reddish-brown broth, a chemical stew of unimaginable proportions, extending for thousands of miles, a truly alien seascape, a canvas of rust. As oxygen reacted with this dissolved iron, it formed insoluble iron oxides, which are essentially rust, turning the iron from a soluble state into solid particles, causing them to precipitate out of the water and settle onto the seafloor in thick, heavy layers. forming vast red sediments that accumulated over millennia, building up immense geological formations. These layers, often alternating with layers of silica, are known as banded iron formations, striking geological strata of alternating red and gray layers, visible in rock outcrops across continents, which are still mined today for much of the world's iron and serving as a dramatic geological record of this ancient event. A testament to the power of microscopic life to reshape a planet's very geology, leaving an indelible global mark visible in rock formations across continents. A silent monument to the oxygen revolution. A record of Earth's chemical transformation. This was the first great act of planetary engineering, a slow geological process that transformed the very chemistry of the oceans, effectively cleaning the water of its dissolved metals, turning it from a murky, iron-rich broth to something clearer, something closer to the waters, A gradual clearing of the primeval soup, a visible change in the planet's aquatic face, from a turbid rust-colored brew to a more translucent blue-tinged expanse. A world slowly revealing its true colors, a new color in the cosmos, a sign of life's growing power and influence. The process was so slow, so gradual, that no single organism would have perceived the change. Yet collectively, they were altering the very foundations of their world. Once the oceans were saturated with oxygen and the vast reserves of dissolved iron had largely precipitated, forming those deep, rust-colored bands on the seafloor, unable to absorb any more oxygen, the newly produced oxygen began to bubble out of the water and accumulate in the atmosphere. This was a slow, painstaking process, taking hundreds of millions of years, as the gas slowly built up in the air, molecule by molecule, layer by layer, until it reached significant concentrations, changing the very breath of the planet, making it breathable for future life. Imagine the sky, which had been a perpetual murky reddish-orange, perpetually overcast with volcanic gases and methane haze, slowly, imperceptibly beginning to lighten, to clear, to reveal hints of blue, a gradual unveiling of the true color of the heavens, a slow dawn that stretched over continents, bringing with it a subtle shift in the very light that touched the earth, a new quality of light and clarity. Over vast stretches of time, as the oxygen levels climbed, the sky would have gradually shifted from a dull, hazy brown to a faint, pale blue, and eventually to the vibrant, clear blue you see today, a profound visual transformation that signaled a new era, a new kind of planet. A world that was now truly breathable for complex life. This was the Earth taking its first true breath of oxygen, a breath that would change everything, making complex life possible, laying the foundation for all macroscopic life. As oxygen accumulated in the upper atmosphere, it was bombarded by high-energy ultraviolet radiation from the sun, which caused some oxygen molecules, O2, to split apart into individual oxygen atoms, O. These highly reactive individual atoms then recombined with other oxygen molecules to form ozone, O3, creating the first rudimentary ozone layer. This ozone layer, though thin at first, began to effectively shield the Earth's surface from harmful ultraviolet radiation, which had previously made terrestrial life impossible by destroying complex organic molecules, opening up the land for future colonization by plants and animals, a protective shield forming in the sky, a vital barrier against the sun's destructive power, a blanket of protection woven by the very life that had altered the planet, allowing life to eventually crawl out of the oceans and thrive on land. This protective layer was a crucial prerequisite for the development of terrestrial ecosystems, allowing life to escape the aquatic cradle. However, this rising oxygen was not a universally welcome change. For the vast majority of the existing anaerobic life forms, which had evolved and thrived in an oxygen-free world, this new gas was a deadly poison, a corrosive, reactive element that attacked their delicate cellular machinery, disrupting their metabolic processes and destroying their membranes, effectively burning them from within. Oxygen, being highly reactive, would have rapidly damaged their cellular structures, effectively burning them from the inside out, causing cellular collapse and death. A microscopic holocaust on a planetary scale. This led to the first great mass extinctions on Earth, a silent microscopic culling on a scale almost unimaginable, affecting countless microbial lineages, wiping out entire forms of life that could not adapt, even before complex life had truly emerged. Billions upon billions of microscopic organisms, unable to adapt to the changing atmospheric conditions, unable to develop defenses against this new poison, perished, leaving behind only those few lineages that could either tolerate oxygen by developing antioxidant defenses and specialized enzymes to neutralize its harmful effects, like superoxide dismutase and catalase, or even better, learn to utilize it for energy, developing aerobic respiration. This was a revolutionary metabolic process, far more efficient than anaerobic pathways, as it used oxygen to fully break down organic molecules, releasing much more energy, ATP, which would fuel the evolution of larger, more complex organisms, providing them with abundant energy for growth and movement, for building intricate structures and developing specialized functions, a true energetic revolution. This was a brutal culling, a planetary cleansing that paved the way for a new kind of biology, a new era of life that could thrive in an oxygen-rich world, a world that was now fundamentally different, a world transformed forever by the actions of its smallest inhabitants, a world reborn, ready for the next stage of evolution. The Earth became a different planet, a blue planet, ready for the next great leap in evolution, a world that was now breathable for you. The air you breathe, the blue sky you see, the very protective layer that shields you from the sun's harsh rays, are direct legacies of these ancient microscopic pioneers and the cataclysmic, yet ultimately life-giving, change they wrought. A testament to the power of tiny, unseen forces shaping the entire globe over eons, creating the world you now inhabit. A world fundamentally shaped by life itself, a world awaiting its next grand act, the emergence of complexity and the rise of giants. For another billion years after the transformative oxygen revolution, after the great cleansing of the atmosphere and oceans, after the planet had taken its first true breath, life remained stubbornly single-celled. Though the presence of oxygen had already begun to drive new forms of metabolic complexity and cellular innovation, pushing the boundaries of what a single cell could be. The planet was now a vast microbial soup, teeming with diverse prokaryotes, those simple ancient cells that lacked a nucleus, and alongside them, the newly evolved, more energetic eukaryotes, a revolutionary cellular design that would prove pivotal for all future complex life, including the very cells that make up your body. This era, beginning around 2 billion years ago, saw the appearance of these first eukaryotes with true nuclei, a leap in internal organization that allowed for greater specialization and efficiency, a quantum jump in cellular architecture, like the difference between a simple hut and a grand, multi-roomed mansion, complete with specialized rooms and internal transportation systems. Imagine these cells as significantly larger and vastly more complex than their prokaryotic ancestors, sometimes thousands of times larger in volume. A leap in internal organization that allowed for greater specialization and efficiency. like the difference between a simple hut and a grand mansion. Instead of a simple, open internal structure where genetic material floated freely in the cytoplasm, unprotected and unorganized, vulnerable to damage, eukaryotes developed a distinct nucleus, a membrane-bound compartment that housed their precious genetic material, DNA, protecting and organizing it, much like a central command center or a protected library of blueprints, ensuring the integrity and efficient management of their genetic code, allowing for more complex genetic regulation. But the innovation didn't stop there. They also developed other specialized internal compartments, called organelles, each performing specific functions, creating an intricate internal division of labor within a single cell, a miniature factory with dedicated departments working in concert. Among the most crucial were the mitochondria, which were essentially tiny powerhouses that could efficiently use the newly abundant oxygen to generate vast amounts of energy, ATP, through aerobic respiration, a far more effective way to fuel a cell than anaerobic metabolism, providing the sheer energy needed for greater size and complexity, for movement, for growth, for reproduction, for building intricate structures. Scientists believe mitochondria were once independent prokaryotic bacteria that were engulfed by a larger host cell and formed a symbiotic relationship, a process called endosymbiosis, where both organisms benefited. The host gained efficient energy production, and the engulfed bacterium found a stable, protected environment within the larger cell, a truly revolutionary partnership that fundamentally altered the course of cellular evolution. Similarly, in early plant-like eukaryotes, chloroplasts, the sites of photosynthesis, are also believed to have originated from engulfed photosynthetic cyanobacteria, another monumental endosymbiotic event, giving these cells the ability to harness sunlight directly, creating their own food, becoming self-sufficient energy producers, laying the foundation for all plant life. This endosymbiotic theory explains the remarkable complexity and energetic efficiency of eukaryotic cells, a massive evolutionary advantage, allowing for much larger and more energetic cells, capable of more complex functions and sustained activity, laying the groundwork for all advanced life forms, from fungi to plants to animals. The development of a sophisticated endomembrane system, including the endoplasmic reticulum for protein and lipid synthesis, and Golgi apparatus for modifying, sorting, and packaging proteins, allowed for efficient protein synthesis and transport, creating complex cellular machinery. Meanwhile, a dynamic cytoskeleton, a network of protein filaments, provided structural support, allowed for internal transport of molecules, and enabled cells to change shape, move, and even engulf other cells, leading to greater cellular complexity and adaptability, a true mastery of internal organization and dynamic function. The ability to move and engulf other cells also led to the evolution of predation at the microscopic level, driving further diversification and an evolutionary arms race among single-celled organisms. With these more efficient and complex eukaryotic cells, the possibilities for life expanded dramatically. Individual eukaryotic cells, still microscopic, began to experiment with cooperation, a fundamental shift from pure competition to collaborative existence, the new way of living that would unlock unprecedented levels of biological organization and allow for the creation of macroscopic life, visible to the naked eye. Instead of simply living as independent units, each fending for itself, surviving and replicating in isolation, some single-celled organisms began to form colonies. Imagine these as loose aggregations of identical cells, perhaps clinging together in a gelatinous blob, like a shimmering, translucent jelly, or forming simple filaments, like strings of beads, stretching for lengths in the shallow waters, absorbing sunlight or nutrients from their surroundings, creating visible mats or strands. At first, these colonies were simple. Each cell could still perform all life functions independently, capable of surviving on its own if separated from the group, merely benefiting from being part of a larger, more resilient cluster, perhaps for better nutrient absorption or defense against microscopic predators. But over time, driven by environmental pressures and the advantages of scale, a division of labor began to emerge within these colonies. A specialization of tasks, a true biological innovation that led to greater efficiency and the formation of true organisms. Some cells might specialize in reproduction, dedicating all their energy to propagating the next generation. Others in feeding, developing structures to capture nutrients more efficiently. And still others in anchoring the colony to a surface or in defense against microscopic predators, sacrificing their individuality for the good of the group, becoming interdependent, their survival linked to the collective. This specialization, however rudimentary, was the crucial first step towards true multicellularity, where cells become interdependent, unable to survive alone, their fates intertwined, their survival linked to the collective, forming a cohesive, functional unit greater than the sum of its parts, a true organism with specialized tissues and organs. Picture these early colonial and truly multicellular forms as soft, jelly-like mats or simple, frond-like structures clinging to rocks in the shallow seas, utterly unlike anything you would recognize as an animal or plant, resembling strange, alien carpets or delicate seaweeds. Yet they were the precursors, the very first architects of complex life, paving the way for the grand diversity that would follow. This allowed for larger body sizes, which offered advantages like better defense against predation, being too large to be engulfed by single-celled predators, and more efficient resource acquisition, reaching into different layers of water or light. New ways to interact with the environment, and greater resilience against environmental fluctuations, paving the way for greater complexity and diversity. A silent revolution of biological cooperation unfolding over hundreds of millions of years, leading to the first macroscopic life forms. Then, around 540 million years ago, after billions of years of microbial evolution, after the Earth had been dominated by single-celled life, after the long, patient wait, a new chapter burst forth with astonishing speed. The planet witnessed an explosion of life unparalleled in its history, the Great Cambrian Explosion. This was not an instantaneous event, a sudden burst of creation from nothing, but a relatively rapid diversification of complex multicellular organisms over tens of millions of years. A geological blink of an eye, yet an incredibly dynamic period of biological innovation, a crucible of new forms, a true evolutionary fireworks display, filling the oceans with a riot of new life. Imagine the oceans, which had previously been dominated by simple, soft-bodied creatures, resembling mere bags of cells or simple tubes, leaving little fossil record, suddenly bursting forth with an astonishing array of new forms, a riot of biological innovation, a kaleidoscope of bizarre and wonderful shapes, a parade of alien designs, each experimenting with different body plans and ecological strategies. This was the dawn of true animal life, the emergence of the major animal phyla we see today, setting the blueprint for all future animal diversity, a blueprint that still largely holds, from worms to fish to humans. For the first time, creatures developed hard parts, such as shells and exoskeletons made of chitin or calcium carbonate, providing crucial protection from predators and essential support for larger body sizes, allowing them to move more efficiently and grow bigger, creating a whole new dimension of interaction, a new form of defense and locomotion. enabling them to burrow, crawl, and swim more effectively. You would see the appearance of trilobites, ancient arthropods with segmented bodies and hard, articulated shells, like intricate, ancient insects of the sea, scuttling across the seafloor, leaving intricate tracks in the mud, their many legs moving in unison, filtering detritus or scavenging, dominating the Cambrian seas in vast numbers. They ranged from tiny, finger-sized creatures to forms as large as dinner plates, demonstrating remarkable diversity within their group. Anomalocaris, a fearsome, segmented predator of the Cambrian seas, with large, compound eyes and grasping appendages that resembled a pair of shrimp, would have terrorized smaller creatures, its presence driving an evolutionary arms race, forcing prey to evolve defenses and escape strategies, leading to a rapid escalation of biological innovation, a constant push for survival, a dynamic interplay between hunter and hunted. Pikaia, a small worm-like creature with a primitive notochord, a flexible rod that supported its body, represented one of the earliest known chordates, a distant, humble ancestor of all vertebrates, including yourself, a tiny, unassuming creature that held the promise of all future backboned life, a crucial link in your lineage, a silent harbinger of future complexity. Other strange and wonderful creatures populated these seas. Wiwaxia, with its soft, slug-like body covered in rows of hard, spiny plates and 2 rows of long, sharp spines for defense, resembling a walking pincushion. And Opabinia, a truly bizarre creature with 5 stalked eyes, a long, flexible proboscis ending in a grasping claw, and a fan-like tail, illustrating the experimental nature of early evolution, where many unique body plans were tried and discarded, only the most successful surviving. The rapid increase in atmospheric oxygen, the evolution of genetic toolkits, like Hox genes, that allowed for complex body plans to be built from simple genetic instructions, and the development of sophisticated predator-prey relationships, are all thought to have contributed to this explosive diversification, creating a dynamic feedback loop of evolutionary change. Crucially, the Cambrian explosion also saw the evolution of sophisticated sensory organs, most notably complex eyes. Imagine the profound impact of sight on these early creatures. Suddenly, the world was no longer just a collection of chemical gradients and tactile sensations. It was a visual landscape, rich with information, with light and shadow, with form and movement, a whole new dimension of perception that transformed their interaction with the environment, opening up a world of visual cues. Predators could actively hunt, tracking their prey with precision, using their newly acquired vision to pursue, their compound eyes, like intricate mosaics, giving them wide fields of view, allowing them to spot movement from a distance, and prey could actively evade, spotting danger from a distance, developing camouflage or speed to escape, developing their own strategies of defense, leading to a constant evolutionary dance, a biological arms race driven by vision. This arms race between predator and prey drove further rapid evolution, leading to an incredible diversity of body plans and survival strategies, a constant push and pull of innovation and counter-innovation, a dynamic feedback loop that accelerated evolution, creating ever more complex and specialized forms, each trying to outwit the other. Life became dynamic, interactive, and increasingly complex. A vibrant, competitive arena where new forms constantly emerged, filling every conceivable niche in the vast, ancient oceans, from the seafloor to the open water, from shallow reefs to deep abysses. The oceans, once a silent, murky realm of simple cells, were now a vibrant, bustling ecosystem, filled with bizarre and wonderful creatures, the ancestors of almost all modern animal phyla, a testament to the power of evolution and the endless possibilities of biological innovation. The stage was set for life to conquer new frontiers, to emerge from the water and explore the vast, empty land, for the next grand chapter of life's unfolding story, a journey that would eventually lead to the world, a world teeming with macroscopic life. Following the Cambrian explosion, a period of astonishing biological innovation that filled the oceans with complex life, life continued its slow, inexorable march towards ever greater complexity and diversification, filling every available niche in the burgeoning oceans, evolving into an astonishing array of forms, from the smallest plankton to the largest predators, a rich, vibrant underwater world that was constantly changing and adapting. For hundreds of millions of years, spanning the Ordovician, Silurian, Devonian, Carboniferous, and Permian periods, marine life dominated the planet, evolving through various periods like the Ordovician, Silurian, and Devonian, each bringing new innovations and new forms of life that adapted to the changing global conditions, to shifting continents and climates, to rising and falling sea levels. Imagine the oceans as vast, bustling ecosystems, teeming with an astonishing array of invertebrates, colossal cephalopods like the orthocones, ancient relatives of squid and octopuses, but encased in long, conical shells, some stretching for many feet, propelling themselves through the water with jets of water. Powerful predators of the ancient seas, their eyes keen and intelligent, their tentacles grasping prey. Intricate corals forming vast, colorful reefs, towering structures built by tiny polyps, providing shelter and sustenance for countless smaller creatures, creating underwater cities that rivaled any terrestrial landscape in their complexity and biodiversity, teeming with life in a vibrant, three-dimensional structure. And then came the fish, the vertebrates, evolving from their humble notochord ancestors. From jawless forms, like early hagfish and lampreys, scavenging the seafloor, to the first armored placoderms, heavily plated and formidable, resembling living tanks, patrolling the depths, their scales glinting in the filtered light, their powerful jaws crushing prey, the early kings of the seas, a true revolution in aquatic predation, setting the stage for all future vertebrate evolution, a lineage that would eventually lead to you. Life was still largely confined to the water, a rich, vibrant world beneath the waves, a complex tapestry of ecosystems, while the land remained a barren, desolate expanse, exposed to harsh ultraviolet radiation and the relentless elements, seemingly lifeless and inhospitable, a vast, silent, empty frontier, a stark contrast to the teeming oceans, a challenge waiting to be met. But the stage was set for another monumental transition, a bold leap into the unknown, a daring venture into a new, challenging environment that held immense potential: the land. Around 470 million years ago, during the Ordovician period, a new frontier beckoned, inviting life to extend its reach beyond the comforting embrace of the oceans, to explore the vast, empty continents. Imagine the first tentative steps as plants colonized land. These were not the towering trees or lush forests, with their intricate root systems and vast canopies, but simple, resilient, moss-like structures, clinging to damp rocks near ancient shorelines, gradually forming thin, green mats, barely visible against the stone, a fragile green film slowly spreading across the barren landscape, a subtle but profound transformation. They developed rudimentary root systems, not for deep anchoring, but to absorb precious nutrients from the meager soil and hold themselves against winds, and protective cuticles, a waxy outer layer to prevent desiccation under the harsh sun, a vital adaptation against the constant threat of drying out in the open air, a battle against evaporation, a crucial innovation for terrestrial survival. This was a slow, arduous process, a battle against gravity and dryness, against the relentless pull of desiccation, against the lack of water for reproduction, as early land plants still relied on water for spore dispersal. But once plants established a foothold, they began to fundamentally transform the terrestrial environment. Their decaying matter began to form the very first soil, creating new habitats and stabilizing the rocky surface, paving the way for more complex plant life, and eventually, animal life. Crucially, they fundamentally altered the very chemistry of the atmosphere by drawing down vast amounts of carbon dioxide through photosynthesis and releasing more oxygen, further enriching the air, making it more breathable for future life, changing the very composition of the global atmosphere, setting the stage for more complex terrestrial ecosystems. A silent green revolution that transformed the entire planet. The evolution of vascular tissue, allowing for water and nutrient transport, and lignin, providing structural support, would later enable plants to grow taller, forming the first true forests. With plants providing a new food source and shelter, a rich banquet of green energy, the animal kingdom began its own cautious expansion onto land. The first true pioneers were the insects and other arthropods, becoming the first animals to truly conquer the terrestrial realm, their exoskeletons providing vital support against gravity and protection against desiccation, acting as internal skeletons and protective armor, a pre-adaptation for land life. Imagine the first arthropods, perhaps resembling giant millipedes or scorpions, venturing out of the water, adapting their exoskeletons to support their weight against gravity and to retain moisture in the dry air, their segmented bodies moving slowly over the damp rocks, feeling the unfamiliar sensation of air on their bodies, their legs scuttling across the nascent land. They were the pioneers of the terrestrial animal world, rapidly diversifying into a myriad of forms, adapting to every available niche, from the damp soil to the dry air, from scavenging to predation. Early winged insects, like colossal dragonflies with wingspans of over 2 feet, such as Meganeura, would take to the skies, buzzing through the ancient air, becoming the first aerial predators, their iridescent wings catching the dim sunlight. A true mastery of a new dimension. A vibrant aerial ballet of life and death. Other insects scuttled through the growing undergrowth, feeding on the primitive plants, their populations exploding, forming the base of the new terrestrial food webs, providing sustenance for future predators. The land, once barren and silent, was slowly becoming green and buzzing with life, a symphony of new sounds and movements, a vibrant, emerging ecosystem that was expanding with every passing million years, a testament to life's relentless drive to explore and adapt, to fill every available space. Next came the vertebrates, a lineage that would eventually lead to you. A story of an aquatic creature learning to breathe air and walk on solid ground. A profound transformation that began with a humble fish. Around 375 million years ago, in the Devonian period, often called the Age of Fish, the first creatures with backbones made the audacious leap from water to land. Imagine the evolution of amphibians, fish with sturdy, lobe-like fins that gradually transformed into limbs, complete with digits, the earliest fingers and toes, allowing them to drag themselves onto land for short periods, perhaps to escape aquatic predators or find new food sources, or even bask in the sun's warmth, gathering heat from the land, their bodies slowly adapting to the new medium, a clumsy but revolutionary gait. They were still tied to water for reproduction, their jelly-like eggs needing moisture to develop, and their larval stages requiring an aquatic environment, like tadpoles. But they represented a crucial bridge between aquatic and terrestrial life. A fascinating transitional form, a bold experiment in adaptation, a true stepping stone for all future land vertebrates. You might see them, clumsy and awkward, pulling themselves onto muddy banks, their skin glistening with moisture, their eyes blinking in the unfamiliar air, their movements slow and deliberate but determined, driven by an ancient urge to explore, to survive, to find new opportunities in this new, challenging world. Following the amphibians, a more fully terrestrial group emerged, the reptiles. Imagine these creatures, around 310 million years ago, in the Carboniferous period, developing a revolutionary adaptation that freed them completely from the water for reproduction, the amniotic egg. This self-contained egg, with its protective, leathery shell, internal membranes, like the amnion, chorion, and allantois, that provided a watery environment for the embryo and facilitated gas exchange and waste disposal, and a supply of yolk for nourishment, allowed reptiles to lay their eggs on dry land, completely severing their reproductive ties to water. This newfound freedom allowed them to colonize vast new inland territories, away from the coasts and swamps, leading to an explosion of diversity and dominance across the continents. They diversified rapidly, evolving into a wide array of forms, from small, agile, lizard-like creatures scuttling through the undergrowth to powerful sail-backed synapsids, early mammal-like reptiles, dominating the Permian period, their unique features adapted to new environments, their bodies efficient and resilient on land, capable of regulating their temperature more effectively than amphibians. This period also saw the development of more efficient lungs and stronger limbs, allowing for greater mobility and activity on land, enabling them to pursue prey and escape predators more effectively. Then, around 230 million years ago, after a cataclysmic mass extinction event, the Permian Triassic extinction, which wiped out over 90% of marine species and 70% of terrestrial vertebrate species, largely due to massive volcanic activity and climate change that led to widespread ocean anoxia and global warming that cleared the way, making room for new forms of life to dominate. A new lineage of reptiles began to rise to prominence. The dinosaurs. Imagine these magnificent, terrifying creatures, evolving from smaller, agile ancestors, gradually becoming the dominant life forms on Earth, filling every ecological niche on land, sea, and air, establishing an unparalleled reign that would last for an immense span of time. For an astonishing 165 million years, spanning the Triassic, Jurassic, and Cretaceous periods, the dinosaurs truly ruled the planet. A reign of unparalleled duration and diversity, a golden age of giants, a period of reptilian supremacy. Picture colossal sauropods, like Brachiosaurus or Diplodocus, their long necks reaching for the highest leaves, their immense weight shaking the ground with every deliberate step, their sheer size defying imagination, living mountains of flesh, peacefully grazing in vast herds across vast plains, consuming tons of vegetation daily. Imagine fierce predators like Allosaurus, with its powerful jaws and razor-sharp teeth, pursuing swift prey, and much later, the mighty Tyrannosaurus rex, a walking engine of destruction, weighing several tons, with bone-crushing jaws, their roars echoing across the vast primeval forests, striking fear into the hearts of all other creatures, their every movement a threat, a hunter of epic proportions, a true apex predator, a symbol of raw power. The skies were dominated by pterosaurs, not true dinosaurs but closely related winged reptiles, gliding on leathery wings, some as large as small planes, like Quetzalcoatlus, soaring silently above, casting immense shadows over the landscape, catching fish or hunting small dinosaurs from the air, mastering aerial locomotion, becoming the first true flyers. And the oceans teemed with marine reptiles like ichthyosaurs, sleek and dolphin-like, their streamlined bodies perfectly adapted for fast pursuit in the water, and plesiosaurs, with their long, serpentine necks and paddle-like limbs, gracefully undulating through the waves, ruling the waves, their forms perfectly adapted to the aquatic realm, formidable predators of the deep, a diverse and powerful marine ecosystem. The world was a verdant, tropical paradise for much of this era, with vast forests of conifers, cycads, and ferns, towering trees forming dense canopies, supporting an incredible diversity of reptilian life, a world of lush green and colossal beasts, a vibrant, complex ecosystem that thrived under the reign of the dinosaurs. A long, glorious chapter in Earth's history, a testament to the power of evolution to produce creatures of immense size and terrifying beauty. For an unimaginable 165 million years, the dinosaurs reigned supreme, casting their colossal shadows across the earth, their dominance seemingly unchallengeable, an unbroken dynasty of giants, their forms having evolved to fill every ecological niche, from tiny forest dwellers to titanic predators, a true testament to evolutionary success. Mammals, your distant ancestors, existed during this time, but they were small, nocturnal, and largely insignificant. Scurrying in the shadows, living a precarious existence, often hiding from the reptilian overlords, their lives defined by evasion and survival in the margins, a quiet, unseen struggle for existence. They were tiny, shrew-like creatures, often burrowing or living in trees, surviving on insects and seeds, their lives a constant struggle against the giants, a testament to their quiet perseverance, their very existence a whisper in the age of roars, a subtle underlying current of life, patiently waiting for their moment. But then, around 66 million years ago, the seemingly eternal reign of the dinosaurs came to a cataclysmic, abrupt, and violent end. An event that reshaped the entire planet and dramatically altered the course of life on Earth, wiping the slate clean for a new era, a new chapter of life's story. Imagine the terrifying moment: a colossal asteroid impact, a rock perhaps 6 miles wide, an object the size of a small mountain slammed into the earth near what is now the Yucatan Peninsula in Mexico, with unimaginable force, releasing energy equivalent to billions of atomic bombs, an explosion that dwarfed anything humanity has ever conceived, a true planetary wound, a scar on the face of the Earth. The immediate impact would have caused unimaginable devastation. A blinding flash of light brighter than 1,000 suns, instantly vaporizing everything within miles, creating a superheated fireball, a colossal explosion that dwarfed any volcanic eruption, sending shockwaves through the atmosphere and crust, and a massive tsunami that would have swept across entire continents, crashing inland for hundreds of miles, devastating coastal regions, followed by seismic shockwaves that would have circled the globe, shaking the planet to its core, causing widespread earthquakes and volcanic activity, a global tremor that resonated through the entire planet. But the true killer was the aftermath. Vast amounts of dust, ash, and debris, pulverized rock and vaporized water, were thrown into the atmosphere, creating a thick, impenetrable shroud that blocked out the sun for months, perhaps years, plunging the Earth into a perpetual twilight, a global night, cutting off the source of all life, leading to a planetary-scale ecological collapse. This caused a global winter, temperatures plummeting drastically, photosynthesis largely ceasing, killing off plants and collapsing food chains from the bottom up, starving the great herbivores and, in turn, their predators, creating a chain reaction of death across the planet. A mass extinction event of unprecedented scale, wiping out 3/4 of all plant and animal species. The dinosaurs, with their high metabolic rates and reliance on abundant vegetation, were unable to adapt to such rapid and drastic environmental change, with insufficient food and warmth, and largely vanished, leaving behind only their avian descendants. Birds, the sole survivors of that mighty lineage, a living connection to the age of giants. Their flight a symbol of adaptation and survival, a feathered legacy that still graces our skies. With the dinosaurs vanishing after the asteroid impact, a vast ecological niche opened up, creating an unprecedented opportunity for the surviving mammals. A sudden, dramatic release from ancient pressures that had kept them small and hidden for so long. Imagine a world suddenly free from the constant threat of giant predators, a world ready for new forms of life to flourish, a blank slate for evolution, a vast, open stage awaiting new actors, new forms of life to rise and claim their place in the sun. The few surviving mammals, small, resilient, and adaptable, often burrowing creatures that could survive the initial impact and the subsequent cold by sheltering underground, feeding on seeds, insects, or detritus, began to rapidly diversify and evolve, taking advantage of the newly available resources and habitats that the dinosaurs had once occupied. A true evolutionary explosion, filling every empty ecological role. This was the dawn of the age of mammals, a period of explosive evolutionary radiation, where new forms emerged with astonishing speed, filling the empty ecological roles left behind by the dinosaurs, rapidly expanding into new shapes and sizes, from the tiny to the truly colossal. Picture them evolving from tiny, shrew-like creatures into a myriad of forms, each adapting to new ways of life. Early rodents gnawing their way through new food sources, their populations exploding and diversifying rapidly. Hoofed animals grazing on the recovering vegetation, forming vast herds across newly greened plains, becoming the new dominant herbivores. Powerful carnivores hunting the burgeoning herbivores, developing new predatory strategies and becoming apex predators, the new kings and queens of the land. And eventually, the ancestors of whales returning to the sea, evolving streamlined bodies for aquatic life, and bats taking to the skies, developing wings of skin stretched between elongated fingers, filling every available niche, conquering new realms of air and sea, demonstrating incredible adaptability and versatility, a true mastery of all environments. Their key adaptations, such as warm-bloodedness, endothermy, allowed them to regulate their internal temperature, giving them a significant advantage in the post-impact cold, allowing them to remain active when cold-blooded reptiles could not, and to thrive in a wider range of climates, from polar regions to deserts. The development of insulating fur provided further protection against the cold, and live birth followed by lactation, feeding young with milk, allowed for more protected and prolonged parental care, increasing offspring survival rates and fostering complex social bonds, leading to the development of nurturing behaviors. Specialized teeth and digestive systems allowed them to exploit a wider range of food sources, from plants to insects to other animals, giving them flexibility in a changing world, a true adaptive radiation that reshaped the planet's fauna. As the Earth recovered from the impact, the climate gradually stabilized, warming and becoming more humid, and forests spread across vast continents, replacing the devastated landscapes, creating new, rich environments, a green renaissance across the globe. a return to lushness. These were not the ancient conifer forests of the dinosaur era, but new, diverse angiosperm, flowering plant forests, which had also been diversifying rapidly, providing abundant food, fruits, nuts, leaves, nectar, and complex arboreal habitats. A rich, three-dimensional world of branches and canopies, teeming with life, offering shelter and sustenance for a new generation of creatures. This lush, three-dimensional environment was crucial for the evolution of a particular group of mammals, the primates. Imagine these early primates, small, agile creatures, evolving in the dense canopies of these new forests. Their lives intimately tied to the trees, their existence defined by their arboreal home. They developed adaptations perfectly suited for life in the trees, grasping hands and feet with opposable thumbs, allowing them to cling to branches with incredible strength and manipulate objects with dexterity, plucking fruits and insects, precisely grasping their environment, a key to their success and a precursor to tool use. Stereoscopic vision, forward-facing eyes with overlapping fields of view, providing excellent depth perception for navigating complex arboreal environments, accurately judging distances for leaps and swings through the branches, crucial for survival in a three-dimensional world where misjudging a leap could be fatal. And relatively large brains compared to other mammals, allowing for complex social interactions, problem-solving, and improved memory, crucial for navigating a complex, ever-changing environment, for remembering food sources and avoiding predators, for learning and adapting, for developing social strategies. You might see them leaping from branch to branch, their long tails providing balance, their keen eyes scanning for ripe fruit or lurking snakes, their bodies moving with graceful agility, a fluid dance through the canopy, perfectly at home in the swaying branches, masters of their arboreal domain. Over millions of years, these primates diversified, evolving into various lineages, some remaining strictly arboreal, specializing in tree-dwelling life, others eventually adapting to life on the ground, as the forests gave way to more open woodlands and savannas, driven by climate change and ecological shifts, forcing them to explore new ways of life and new food sources. This adaptation to both trees and ground would be a crucial step, providing flexibility and opening up new opportunities for foraging and locomotion, allowing them to exploit a wider range of environments and resources, a key factor in their eventual dominance and diversification. It was a slow, deliberate process, driven by environmental pressures and the ceaseless march of evolution, a journey of countless generations, patiently shaping new forms, setting the stage for the most remarkable story of all, the emergence of humanity, the ultimate terrestrial primate, a creature poised to transform the world, a story that would culminate in your very own existence, a testament to the power of adaptation and the relentless drive of life. After billions of years of planetary formation, chemical evolution, the rise of single-celled life, the oxygen revolution, the emergence of multicellularity, the colossal reign of the dinosaurs, and the subsequent rise of adaptable mammals and agile primates. Our journey through time finally brings us to the most recent chapter, the very culmination of this grand narrative. The appearance of you, humans, Homo sapiens, appeared approximately 300,000 years ago in Africa, a mere blink of an eye in the vastness of Earth's history, a fleeting moment in geological time, yet a period of unparalleled transformation, marking the dawn of consciousness and complex culture, the beginning of a new kind of planetary influence, a species capable of shaping its own destiny. Imagine these early humans, not so different from you in fundamental form, with the same skeletal structure, and basic cognitive capacity, but living a life utterly alien to your modern sensibilities, a life stripped bare of all technological comfort, a profound connection to the raw essence of existence, the beating heart of the wild earth, a life of immediate visceral experience, driven by instinct and ingenuity. Life was lived in small tribes, intimate nomadic groups of perhaps 20 to 150 individuals, constantly moving across the vast, unbroken landscape in search of food and water, following the seasons and the migrations of animals. Their existence a perpetual journey dictated by the environment's rhythms, by the abundance and scarcity of resources, a constant dance with nature, a nomadic existence. There were no permanent settlements, no cities with their towering structures of stone and steel, no fixed homes beyond temporary shelters constructed from branches and leaves, quickly assembled and just as quickly abandoned, or the occasional use of caves and rock overhangs for brief respite, always on the move, always adapting to new territories, never truly settling in one place for long. The concept of property, of owning land or resources beyond what was immediately needed for survival, was largely non-existent. Everything was shared, everything was communal, governed by the immediate needs of the group and the unspoken rules of survival. A deep, ingrained sense of collective responsibility and shared fate. A true communal existence where cooperation was paramount. Their existence was entirely intertwined with the natural world, dictated by its rhythms and resources, a constant dance with the environment, a profound symbiosis that fostered deep ecological knowledge and respect, a wisdom born of direct interaction and observation. Every day was a lesson in observation, every season a challenge of adaptation, every interaction a test of their ingenuity and resilience, a constant learning process, and no clothes at first, only the rough embrace of the sun and wind upon their skin, a direct connection to the elements, an unbuffered experience of the natural world. Imagine yourself and your ancestors moving freely, naked under the vast African sun, your skin exposed to the elements, toughened by sun and wind, by thorns and rough ground, a testament to natural resilience, your senses directly connected to the world around you, unbuffered by artificial layers. Clothing, as a form of protection, warmth, and cultural expression, would come much later, a gradual innovation driven by necessity in colder climates, as they migrated out of Africa into more challenging environments, and the ingenuity of early minds to use animal hides and plant fibers, transforming raw materials into functional garments, a mark of their growing adaptability. Their bodies were their primary tools, honed by constant movement and physical exertion. Their senses their guides, their physical prowess their main defense and means of survival. They relied on their keen eyesight to spot distant game or predators silhouetted against the horizon, their acute hearing to discern subtle movements in the rustling grass or the distant call of a fellow tribe member, and their highly developed sense of smell to track prey or detect danger. Their senses finely tuned to every nuance of the environment, making them master trackers and observers, living in constant, heightened awareness, a symphony of sensory input. Their physical endurance allowed them to cover vast distances on foot, pursuing game or seeking new foraging grounds. Their strength to carry what they needed, their agility to navigate complex terrains, their bodies perfectly adapted for their demanding lifestyle, a testament to millions of years of hominin evolution, a pinnacle of biological fitness for their environment, a living, breathing testament to survival. The discovery and mastery of fire as a new tool was a monumental turning point, a revolutionary leap that fundamentally changed the course of human evolution, separating them decisively from all other animals, a true game-changer that unlocked unprecedented possibilities and transformed their relationship with the natural world, giving them a measure of control. Imagine the initial awe and fear as early humans first encountered fire, perhaps from a lightning strike during a storm or a volcanic eruption, a terrifying, uncontrollable force of nature, destroying everything in its path, yet holding a mesmerizing allure, a source of warmth and light. Then, the incredible ingenuity required to control it, to keep it alive, perhaps by carrying embers in a hollow log or a special container, to nurture it, to carry it from place to place, and eventually, to create it at will through friction, rubbing sticks together rapidly, or percussion, striking flint against iron pyrite. A profound act of intellectual mastery and technological innovation, a symbol of their growing control over the natural world, a testament to their problem-solving abilities and their capacity for abstract thought. Fire provided warmth against the cold nights, expanding their habitable zones into colder regions and allowing them to survive in diverse climates. From savannahs to temperate forests, it offered crucial protection from predators, who feared its light and heat, keeping them at bay from the safety of the campfire's glow, creating a secure perimeter and a place of refuge. It allowed for the cooking of food, making tough meat and fibrous plants more digestible and unlocking more nutrients, fueling brain growth and reducing the energy spent on digestion, a crucial dietary shift that powered cognitive development and allowed for larger, more complex brains. And it became a central point for social gathering, storytelling, community bonding, and the transmission of knowledge from elder to youth, a hearth around which culture could begin to form, a symbol of shared humanity, creating the first true homes and fostering complex social structures, strengthening tribal bonds. It was the first technology that truly allowed humans to reshape their environment and extend their reach beyond their natural biological limitations, transforming them from mere creatures into creators, into masters of their domain, capable of altering their immediate surroundings and eventually the entire planet. A profound shift in their ecological role. Beyond basic survival, their developing minds began to engage with the world in new ways, driven by curiosity and a burgeoning capacity for abstract thought, a desire to understand and express. The creation of more sophisticated tools and technologies became increasingly central to their lives, evolving from simple improvisations to deliberate design and specialized functions. From simple choppers made by striking one stone against another, they advanced to finely flaked stone tools like hand axes, multi-purpose tools for cutting, scraping, digging, and scrapers, crafted with incredible precision and skill, allowing them to butcher large animals, process hides for clothing and shelter, and work wood for various purposes, from digging sticks to rudimentary shelters. They began to use bone and antler to create delicate needles for sewing hides into clothing, intricate fish hooks for new food sources, and specialized points for spears, creating composite tools that were far more effective than simple sticks, demonstrating a mastery of diverse materials. The invention of the atlatl, spear thrower, dramatically increased the range and power of their hunting weapons, making hunting safer and more efficient, allowing them to take down larger, more dangerous prey from a distance, reducing risk. The ability to craft these tools reflected not just manual dexterity, but also sophisticated planning, problem-solving, and abstract thought, thinking multiple steps ahead, visualizing the finished product before it existed, a true mark of intelligence. This burgeoning intellect also led to the development of complex language, allowing for more nuanced communication, the sharing of intricate hunting strategies, the transmission of cultural knowledge across generations, and the ability to articulate abstract ideas about their world. about the past, and about the future, building a shared understanding. This led to the flourishing of art and symbolic expression. Imagine them gathered in the flickering firelight, carving intricate patterns into bone, creating Venus figurines, small statues representing fertility or deities, painting vivid scenes of animals and hunts on cave walls deep underground, their hands guided by an innate desire to express, to understand, to leave a mark, to connect with something beyond the immediate, a spiritual dimension. These cave paintings were not just decorations. They were perhaps records of hunts, spiritual beliefs, teaching aids for the young, or expressions of their relationship with the animal world, reflecting a rich inner world and a burgeoning sense of self, a collective memory. Rituals and ceremonies began to emerge, connecting them to the spiritual realm, to the cycles of nature, to the mysteries of life and death, creating shared meaning and purpose, solidifying their social cohesion. The development of these cultural practices, of shared stories and beliefs, cemented the bonds of the tribe, creating a sense of shared identity and purpose, allowing for cooperation on a larger scale than ever before, fostering altruism and collective action, laying the groundwork for civilization. This was the true emergence of complex culture, a unique human trait, setting them on a path of unprecedented innovation and transformation, a journey that continues to this very day, built upon the profound foundations laid by these early ancestors, a testament to the power of the human mind and spirit, a legacy that lives within you. Now, bring your awareness back to this moment, to your own body, to the present. You're tall, broad-shouldered, with strong hands gripping a wooden spear. Feel the smooth, worn wood against your palm, the weight of the ancient hunting tool, the rough texture of the sharpened tip, honed from flint, the balance of it in your hand, an extension of your will, a connection to your primal past, a tangible link to your ancestors. Your muscles are taut, ready, your senses alive, every nerve tingling, alert to the subtle shifts in the breeze, the distant rustle of leaves, the scent of damp earth, every detail of your surroundings, a heightened state of awareness. The world around you is vibrant, alive, teeming with unseen life, a constant symphony of natural sounds and scents, a living, breathing landscape that demands your full attention, your complete presence. The air smells of recent rain and wild grass, a clean, earthy scent that fills your lungs, invigorating you, connecting you to the very breath of the planet, to the ancient rhythms that shaped it, to the timeless cycles of nature. Around you, others move freely, naked under the sun, their skin tanned and strong, perhaps painted with earth pigments for ceremony or camouflage, strong like carved stone, their bodies honed by a lifetime of physical exertion, every movement efficient and purposeful, a testament to their resilience and adaptation. There are no walls, no artificial barriers separating them from the raw power of nature, from the vast, open expanse of the savannah. No boundaries to their world, only the endless horizon, a symbol of freedom and challenge, a boundless wilderness. There are no phones, no screens, no constant digital distractions, no artificial connections, only the immediate, visceral reality of their surroundings and the direct, unfiltered communication within the group, a profound, intimate bond of shared experience, of silent understanding and shared glances, a true human connection, deep and meaningful, just survival and the primal rhythm of the hunt, the gathering, the shared vigilance, the simple, demanding cycle of life, a profound connection to the earth and to each other, a life lived in raw, unadulterated presence, a deep, ancient understanding. You are a part of this ancient tableau, a living bridge between the deep past and the complex present, embodying the culmination of billions of years of evolution, a testament to the incredible journey of life, a living history, carrying within you the echoes of every step on this extraordinary path. A profound sense of belonging to this ancient lineage, a deep, resonant connection to your origins. Let your thoughts drift through those ages now, through the vastness of cosmic time, feeling the immense weight and wonder of it all, an almost unbearable grandeur that humbles and inspires. Imagine the silent earth in its earliest infancy, a swirling maelstrom of incandescent rock, its fiery birth a spectacle of unimaginable power, constantly bombarded by meteorites and comets, each impact adding to its growing mass, delivering vital water and organic molecules, a world of ceaseless, deafening thunder and searing heat. A cosmic crucible. Picture the endless rain that followed, a planetary deluge lasting millions of years, scalding and relentless, heated by the still warm crust and the greenhouse gases in the atmosphere, slowly carving out the first deep basins that would become oceans, a patient, persistent force shaping the very face of the planet, a liquid hammer forging future landscapes. Consider that this great bombardment phase, roughly 4.1 to 3.8 billion years ago, not only brought water, but also may have delivered a significant portion of Earth's early organic compounds, seeding the primordial soup. See the first sparks of life, tiny, invisible stirrings in the deep, dark oceans, perhaps near the superheated chemical fountains of hydrothermal vents, driving reactions without sunlight. Or imagine them in the warm, shallow pools on the surface, electrified by constant lightning, where simple molecules, perhaps including the fascinating RNA world hypothesis precursors, began their intricate dance. In this hypothesis, RNA, not DNA, was the primary genetic material, capable of both storing information and catalyzing reactions, acting as a molecular jack-of-all-trades, a self-replicating system that predated the more complex DNA protein life we know. These early molecules assembled into the first rudimentary self-replicating forms, perhaps enclosed within simple lipid membranes that spontaneously formed in water, creating the boundary between inside and outside, the very genesis of biology. A truly profound and improbable leap from non-life to life. The conditions within these primordial protocells were distinct from the external environment, allowing for focused chemical reactions and the beginnings of metabolism. Feel the slow, patient breath of oxygen released by ancient cyanobacteria, also known as blue-green algae, which developed a unique photosynthetic pathway that split water molecules, liberating oxygen as a byproduct. This process, spanning hundreds of millions of years, gradually transformed the planet. Initially, this oxygen reacted with dissolved iron in the oceans, forming vast, visible banded iron formations on the seafloor. Spectacular geological evidence of this ancient chemical transformation. Only after the iron sinks were saturated did oxygen begin to accumulate in the atmosphere, slowly turning the murky, iron-rich oceans blue and building a protective atmospheric shield, the first rudimentary ozone layer, formed by UV radiation interacting with oxygen, shielding the surface from harmful ultraviolet radiation and allowing life to eventually colonize land. This was a silent, global revolution that paved the way for all future complexity, a breath that changed the world forever, creating a planet hospitable to macroscopic life. Witness the explosion of forms in the ancient seas, the Great Cambrian explosion, a riot of life bursting forth with unprecedented speed. Typically sighted between 541 and 530 million years ago, a geological blink of an eye. This period saw the sudden appearance of creatures with hard shells, segmented bodies, and the first complex eyes, triggering an evolutionary arms race between predators and prey. Imagine the trilobites, ancient arthropods, scuttling across the seafloor. Their compound eyes, sometimes with thousands of individual lenses, providing an unparalleled view of their environment. Consider the bizarre Anomalocaris, a top predator of its time, reaching lengths of up to 2 meters, with large, stalked eyes and formidable grasping appendages, actively hunting in this newly visual world. This rapid diversification was fueled not only by increased oxygen levels and the development of hard parts, but also by the evolution of sophisticated genetic toolkits, like the Hox genes, master control genes that regulate the development of body plans, allowing for vast variations in morphology from a relatively small set of genetic instructions, essentially providing the blueprint for constructing complex multi-celled organisms, unlocking an explosion of anatomical possibilities. See the colossal giants who once walked the earth, the dinosaurs, reigning supreme for over 165 million years, spanning the Triassic, Jurassic, and Cretaceous periods, their immense footsteps shaking the ground, their roars echoing across vast primeval forests. This was a time of incredible diversity, from the long-necked sauropods like Argentinosaurus, potentially the largest land animal ever, weighing up to 100 tons, to the fearsome Tyrannosaurus rex, whose bite force was estimated at over 12,800 pounds per square inch, capable of crushing bone. Pterosaurs, like the gigantic Quetzalcoatlus, with wingspans of up to 12 meters, soared through the skies, masters of the air, and marine reptiles like the speedy ichthyosaurs and the long-necked plesiosaurs dominated the oceans. Their reign was a testament to their incredible power and adaptation, ruling a verdant tropical world, a true golden age for reptiles. And then, feel the quiet, persistent rise of your ancestors, the early mammals, scurrying in the shadows during the dinosaur era, often small, nocturnal, and insectivorous, but possessed of key adaptations like warm-bloodedness, fur, and lactation that gave them a critical advantage. They survived the cataclysm that ended the Age of Giants, the Cretaceous-Paleogene (KPG) extinction event, caused by a massive asteroid impact near the Yucatan Peninsula 66 million years ago, which plunged the Earth into a global winter, wiping out approximately 75% of all plant and animal species, including most dinosaurs. With the ecological niches cleared, mammals underwent a spectacular adaptive radiation, diversifying rapidly into the myriad forms we see today. Witness the evolution of primates, their grasping hands and keen eyes perfectly adapted to the lush new angiosperm forests that flourished after the extinction event. This arboreal life fostered the development of stereoscopic vision for depth perception, opposable thumbs for manipulation, and relatively large brains for complex social interactions and problem-solving. This lineage would eventually lead to upright walking, bipedalism, freeing the hands for carrying and tool use, leading to greater manual dexterity and the development of increasingly sophisticated tools. The mastery of fire, a truly transformative technology, provided warmth, protection, and allowed for the cooking of food, significantly increasing nutrient absorption and fueling further brain growth. These early Homo sapiens began to shape their own destiny, building communities, creating complex language, developing intricate tools, and weaving the first threads of culture, expressing their inner worlds through cave paintings and symbolic artifacts, leaving an indelible mark on the planet. Feel the profound connection to this endless, unfolding story, to the deep time that shaped you, to the very essence of existence, to the cosmic dust and ancient waters that flow within your veins, to the resilience and innovation of every living thing that came before you. A direct, unbroken lineage stretching back to the dawn of life. You are a living testament to billions of years of cosmic and biological evolution, a product of supernova and primordial oceans, of microbial revolutions and the reign of giants, of the quiet perseverance of your mammalian ancestors, and the unique ingenuity of your human lineage. You carry the echoes of every triumph and every extinction, every adaptation and every innovation within your very being. And as you do, allow yourself to relax completely, to surrender to the gentle current of time, letting it wash over you, smoothing away the edges of the present, to let your consciousness drift through the eons, through the vast, silent stretches of geological time, feeling the slow, immense pulse of the planet, through the rise and fall of countless species, each playing its role in the grand drama of life, through the immense, patient unfolding of life on Earth, from single cells to complex ecosystems, from molten rock to teeming forests, and sleep deeply, profoundly, knowing you are part of this endless, magnificent story of life on Earth, a living, breathing chapter in its grand design, a timeless journey into the heart of existence, a peaceful descent into slumber, carrying the wisdom of the ages within you, the quiet, comforting truth of your place in the universe, a silent, profound understanding of belonging to something far greater than yourself, a cosmic legacy inscribed in your very being.